लॉन्ग आन्सर क्वेश्चनचे आन्सर की आहे. फर्स्ट क्वेश्चन आहे, स्टेट द फर्स्ट लॉ ऑफ थर्मोडायनॅमिक्स अँड फ्रेंड्स, कशा आहात? आज आपण महाराष्ट्र शासनाने शालेय शिक्षण व क्रीडा विभागाने जुई 2023 क्वेश्चन बँक पाठवली होती, त्याची आन्सर की बघणार आहोत. मागील व्हिडिओमध्ये MCQ व्हेरी शॉर्ट आन्सर फर्स्ट, शॉर्ट आन्सर सेकंड कंप्लीट झालेले आहेत फिजिक्स याची थर्मोडायनॅमिक चॅप्टरची. आज आपण लॉंग आन्सर क्वेश्चन बघणार आहोत. चला तर मग लॉंग आन्सर क्वेश्चन बघूया. ही आहेत लॉंग आन्सर क्वेश्चन 4 मार्कीचे एकूण 5 आहेत. यांची आन्सर आपण पुढील प्रमाणे PDF स्वरूपात बघूया. लॉंग आन्सर क्वेश्चनचे आन्सर की आहे. फर्स्ट क्वेश्चन आहे, स्टेट द फर्स्ट लॉ ऑफ थर्मोडायनॅमिक्स अँड डिराइव द रिलेशन बिटवीन द चेंज इन इंटरनल एनर्जी डेल्टा यू, वर्क डन W and heat Q. Answer statement: when the amount of heat Q is added to a system, its internal energy is increased by an amount delta U, and the remaining is lost in the form of work done W on the surrounding. A relation between the change in internal energy delta U, work done W and heat Q. First, when the amount of heat Q is added to the system and the system does not do any work during the process, it is the internal energy increases by the amount delta U is equal to Q. Second, when the system does some work to increase its volume and no heat is added to it, is while expanding the system loses energy to its surrounding and its internal energy decreases. Delta U is equal to minus W. Third, as the internal energy can be changed using both the way, we can consider the total change in the internal energy as delta U is equal to Q minus W 1. This is mathematical statement of the first law of thermodynamics. Question number second. Explain work done during the thermodynamic process. First, consider the system is initially at a state A, with the pressure is Pi and volume is Vi. Let the state be indicated as a coordinate Vi, Pi. It can attain the final state Vf, Pf along the different possible path as shown in the PV diagram below. हे डिफरंट वे टू चेंज अ सिस्टीमची PV डायग्राम आहे. हा प्रेशर इनिशियल, प्रेशर फायनल, व्हॉल्यूम इनिशियल, फायनल हा कर्व काढलेला आहे, बघू शकता. Second, consider a system change in its state from initial state A to final state B via path where 1 as shown in figure. Pressure and volume both change. हे डायग्राम आहे. Point A, when system change itself from A to B, both its pressure and volume change. The pressure decrease while volume increase. B, the work done by the system is given by the area under the curve. It is positive when the volume increases as shown in figure, or negative when the volume decreases. Third, consider the system change its state from A to B via path 2 as shown in figure A. A. In this case, the volume decreases to Vi from the point A up to the point C at a constant pressure Pi. B. After a point C, the pressure of the system decreases to Pf at a constant volume as shown in figure A. Option C. The system thus reaches its final state B with the coordinate VF, PF. Work done in the process is represented by the shaded area under the curve in figure A. Consider the system change in state from A to B with path 3 as shown in figure B. ही figure B आहे. In this case, the pressure decreases from Pi to Pf at a constant volume Vi along the path AD. B. After point D, the volume of the system decreases to Vf at a constant pressure Pf as shown in figure B. C. Work done in this process is represented by the shaded area under the curve in figure B. 5. From the figure A and B, we can conclude that the work done is more when the system flow path ACB, then the work done by the system along the path ADB. Thus, the work done by the system is thermodynamic process depend not only on the initial and the final state but also intermediate state, that is on the path along the change takes place. Question number 3. Explain the thermodynamic of isobaric process. Answer. A thermodynamic process which is carried out at constant pressure, that is delta P is equal to 0, is called isobaric pressure process. Second, for an isobaric process, none of the quantities delta U and Q and W is 0. Third, temperature of the system change, that is delta T is not equal to 0. Fourth, energy exchange is used to do work as well as to change internal energy cause exchange used to do. Fourth, energy exchanged by use to do work as well as change internal energy causing increasing in temperature. Thus, delta Q is equal to delta U plus W. V. As work is done, volume change during the process. Vi. Heat exchange in case of an isobaric process. A. Consider an ideal gas undergoing volume expansions at a constant pressure. B. If Vi and Ti are its volume and temperature in the initial state of the system, and Vf and Tf are its final volume and temperature respectively, the work done in the expansion is given by W is equal to PdV is equal to P into bracket Vf minus Vi is equal to NR in bracket Tf minus Ti. Equation first. C. Also, the change in the internal energy of the system is given by delta U is equal to NCV delta T is equal to NCV into bracket Tf minus Ti. Equation second. where Cv is the specific heat at a constant volume and delta T is equal to Tf minus Ti is the change in its temperature during the isobaric pressure. D. According to the first law of thermodynamics, the heat exchange is given by Q is equal to delta U plus W. Using equation 1 and 2 we get Q is equal to NCV into bracket Tf minus Ti into bracket complete plus Nr into bracket Tf minus Ti. Therefore Q is equal to into bracket NCV plus Nr bracket complete Tf into Tf minus Ti bracket complete. Therefore Q is equal to NCP into bracket Tf minus Ti. Cp is equal to Cv plus R, where Cp is the specific heat at a constant pressure. The PV diagram for a isobaric process is called isobar. It's shown in figure below. Number 4. Explain the thermodynamic of isochoric process. The thermodynamic process in of the system is kept constant. It is called as isochoric process. Second, a system does not work on its environment during an isochoric process. Third, for an isochoric process, delta V is equal to 0, and from the first law of thermodynamics, delta U is equal to Q. Fourth, temperature of the system changes, that is delta T is not equal to 0. Fifth, this means that for isochoric change, all the energy added in the form of heat remains in the system itself and cause an increases in its internal energy. Also, as the volume is unchanged, no work is done. 6. The first law of thermodynamics for isochoric process is delta U is Q is equal to delta U is first equation. The change in internal energy is given by delta U is equal to NCV delta T. Question second. The work done is given by delta is equal to P dV is equal to 0. Since delta V is equal to 0. From equation 1 and second, the heat exchange is given by Q is equal to delta U is equal to NCV delta T. Seventh, PV diagram of isochoric process is as shown below. Question number 5. Explain the thermodynamic of adiabatic process. Answer. First, adiabatic process is a process during which there is no transfer of heat from or the system. Second, for adiabatic change, Q is equal to 0. Therefore, delta U plus W is equal to 0. Therefore, delta U is equal to minus W. Third, this implies for adiabatic expansions, W is a positive and delta U is a negative. That is, when work is done by the system adiabatically, its internal energy decreases. Fourth, similarly, when the system is compressed adiabatically, W is negative and delta U is positive. That is, the internal energy of the system decreases in an adiabatic compression. Fifth, heat transfer to and from the system is prevented by the either perfectly insulating the system from its environment, or by the carrying out the change rapidly so that there is no time for any exchange of heat. 6. Temperature of the change, that is delta T, is not is equal to 0. 7th, usually it is a sudden change and the system does not find any time to exchange heat with its environment. 8. PV diagram for a adiabatic process is shown below. इथे आपला थर्मोडायनॅमिक चॅप्टर संपलेला आहे. व्हिडिओ आवडला असेल तर लाईक करा, शेअर करा, सबस्क्राईब करा आणि बेल आयकॉन दाबायला विसरू नका, कारण नवीन नवीन अपडेट आपल्या चॅनलवरती तुम्हाला मिळत राहतील. धन्यवाद.